Okay, what we're going to do in this video is demonstrate the combined ideal gas law, which involves changing pressure, changing volume, and changing temperature. So I've got a Coke can here, and there's probably a centimeter or two of water in there, and I'm going to heat it up on my gas stove. Again, this is not something I would recommend you do at home. I'm going to do it here because I've done this many times. And then once we heat up and actually get the water to boil in the can, I'm going to invert the can with my tongs into a very cold container full of water, actually ice cold. And we will see what happens. So here we go. We're going to boil the water. And once it gets to boil, you'll probably hear it make some noises. And what will happen is the water that's in there inside the can will vaporize and actually push out some of the air. So we're going to have water vapor, H2O gas, at the same pressure as the air pressure, because this pop can is open, as you can see. Never do this demonstration with a closed pop can. That would make a big mess. And eventually this water will boil. You might even see some condensed water vapor coming out the top of the can as we go here. That's not a problem. The key to this demonstration is to look at what happens with the can and to think about how the pressure changes when the temperature changes as I plunge it into the very ice cold water bath. So let's get this water boiling, maybe even a little bit more. I can certainly hear it heating up. Not quite boiling yet, but we're getting there. Actually, you can see a little bit of boiling on the top of the can there. There is some bubbling going on, and it's starting to heat up pretty good here. And here we go. So the water inside this can is approaching 100 degrees. And of course, the boiling point of water really occurs when the vapor pressure of the liquid below, which is in this case water, exceeds the atmospheric pressure pushing down. So there's a lot of chemistry and physics going on in this famous experiment. Now, I'm going to heat this up just a little bit more before I invert it into my ice cold water bath. Okay, I think we're ready to go. So what I'm going to do is take my tongs, invert the can into the ice cold water bath upside down, which will seal off the top of the can. And you can just be the observers and watch and think about what happens. So here we go. Just as expected. Very dramatic, as you can see. That's impressive. The pop can imploded quite to a large extent here. Obviously, what's happened, if you think about it, the heat inside, the molecules inside the can had a lot of kinetic energy. The temperature of that gas initially was very, very high. And the moment that I plunged the can into the cold container of water, the kinetic energy of the molecules in the can reduced very rapidly. And we know that according to Charles' law, that volume and temperature are proportional. So that volume decreased quite rapidly as the temperature decreased. Also, the pressure inside would have decreased as well. So there you have it, folks. Pressure, volume, and temperature all changing at the same time to produce one of the most famous experiments in all of chemistry, I would argue, the good old imploding can trick.